Let us now study about dielectrics or insulators. So what's meant by a word dielectric or insulator? So we know insulators are the things which do not allow current to pass through. So we can say they are non-conducting materials. That means they don't allow charges to pass through. Materials. Then if you see, they have no free electrons there. There are no free electrons. If you see the opposite here, metal is a conductor. It has free electrons, so charges can flow. But this dielectric is a non-conducting material, so electrons cannot flow there. It has no free electrons. Let's see some examples of this dielectric medium. So first one we say ebonite. Ebonite is a kind of wood. Ebonite. Then glass. Glass is dielectric. That means current cannot pass through it. Then mica. Mica is used in iron boxes. Okay. Then paper. Paper is also a dielectric. Current cannot pass through paper also. So these are examples of dielectrics. Now generally, if you see that the dielectrics, when external electric field is applied, the electrons are not free to move anywhere, but they just get oriented or just get realigned in a specific way. Dielectrics are of two kinds. They are made of two materials. One is polar molecules, other one is non-polar molecules. Let us study about non-polar molecules first. So non-polar molecules. This is the first type of dielectrics. So in a non-polar molecule, what happens is the centers of positive and negative charges coincide. So let's study that. So let me write down the centers of positive and negative charges coincide. Coincide means what? They are in the same place. Then if you see, it has no permanent dipole moment. I'll explain all this one by one. No permanent dipole moment. Let us see some examples for this. Examples: this is hydrogen, H2, hydrogen, then oxygen, O2, then carbon dioxide, CO2. Let's see what happens in a non-polar molecule. They said a non-polar molecule is like this way. Let's take this as non-polar molecule. And then in it, the centers of positive and negative charges. So let me take this as a center here, approximately. Then the centers of positive and negative charges are in the same place. So this is a positive charge plus. And then for minus, let me use this color here. Okay. So what happens is the centers of positive and negative charges are in the same place, so they coincide. And they have no permanent dipole moment. They are not separated. The positive and negative charges are not separated. They don't form a dipole. Then let's see what happens if we keep them in an electric field. So I'll take this molecule here. Then we'll keep two plates here. Let's keep two plates here, metal plates, like this. So the first plate we have positive charges, and on the second plate we have negative charges. The electric field goes from positive to negative charge. So this will be the direction of the electric field, E. It's a vector. Then dipole moment will be from positive to negative. This is the dipole moment, vector. Now let's see what happens. When you keep this in an electric field, the positive charge will be repelled by the positive plate. So the positive charge will go this side, and then the negative charge will come towards the positive plate. So we say they are polarized by the external electric field. Okay, this is called as polarization. That means we are making the molecule into positive and negative parts. Now let us study about polar molecules. Let's study about polar molecules now. In polar molecules, the centers of positive and negative charges are separated even in the absence of electric field. It means if there is no electric field also, the positive negative charge will be separated, and they have a permanent dipole moment. Okay, we learned this in dipoles, remember. So H2O, that means water. That's an example. And N2O means nitrous oxide. This is also called as laughing gas. Okay. Then HCl, that means what? Hydrogen chloride. We use it in hydrochloric acid. Hydrogen chloride. Then this NH3 means ammonia. It's used in cleaning liquids. Now let's see some pictures to show about polar molecules. Let's study about polar molecules. If there is no electric field also, you can see even though there is no electric field, the positive and negative charges are there. They separate, we know, and they are in random directions. See that they are, each one is in each different directions. Now let us see what will happen if we keep an electric field. In this case, there are two metal plates here, or two sheets, and the first sheet we give positive charges, in the second sheet we have negative charges. Now in the center we have this material, and it has a permanent dipole moment, we know. What happens when you give a charge like this, or a positive charge is brought nearby? You can see that the negative charges will be attracted towards the positive charge, and the positive will be repelled. So this side will have negative, and this side will have the positive charges. The molecules tend to rotate and align with the electric field. Now let's see what will be the electric field inside. See at this point what will be the electric field? You see this electric field due to the positive charge here, or the external electric field, you can say external electric field. And this side you have the internal electric field. The internal electric field will be in this direction. It will be slightly less than the external electric field. So this shows that polar molecules get aligned in the direction of the external electric field, and on the left side the negative charges are together. They will form like a sheet of negative charges with the surface charge density minus sigma b, and on the right side the positive charges come together and they have a surface charge density plus sigma b. Now let us study what's meant by polarization. In the presence of an external electric field, a dipole moment is created, or is induced in the dielectric material. So it means in an electric field only there's a dipole moment is produced. So what's my polarization? What's the definition of polarization? Polarization P vector is defined as the total dipole moment per unit volume. Now they say the polarization of a molecule is directly proportional to the electric field. There's more electric field means there will be more polarization. So to remove the proportional sign, we put equal to sign and a constant into electric field. This is a constant here. This constant is a Greek symbol. This is called as pronounced as chi. It's a Greek alphabet. Chi is a Greek alphabet. So what does this means? Chi E means, it means the electric susceptibility. Electric susceptibility. P means the polarization, Chi E means electric susceptibility, E stands for the electric field. So this formula is for polarization.